What if a massive, unseen force has been shaping our solar system for billions of years, right under our cosmic noses? Imagine an architect so grand, its gravitational blueprints dictate the very paths of distant worlds. This isn't science fiction, it's the profound mystery of Planet 9, and its silent, powerful influence is far more significant than you could ever imagine. Far beyond the orbit of Neptune, past the frozen frontiers where the sun's light fades into a pale whisper, lies a region of mystery and silence, the Kuiper Belt. It is a place filled with icy remnants from the birth of our solar system, a cosmic graveyard of frozen worlds that never became planets. For decades, astronomers believed they understood this distant region, imagining it as a scattered collection of space debris quietly orbiting the sun. But then something extraordinary began to emerge, a pattern hidden within the chaos. Strange alignments, impossible orbital clusters, and gravitational whispers hinted that something enormous was lurking in the shadows. Something unseen was shaping the distant edge of our solar system. It was as though a hidden hand, vast and patient, was guiding these icy wanderers through the darkness. This mystery began with a question. Why were certain Trans-Neptunian objects, small, icy worlds far beyond Pluto, moving in such unusual ways? When astronomers began to map their orbits, they expected randomness, a natural scattering caused by billions of years of gravitational interactions. But that's not what they found. Instead, they discovered that these objects were strangely aligned. Their elliptical orbits pointed in nearly the same direction, clustered together in space rather than spread out evenly as expected. It was as if they were following the rhythm of an invisible drummer. The odds of such a pattern occurring by chance were astronomically small. Nature rarely arranges things so neatly without a reason. It was then that scientists began to suspect a hidden influence, something massive, something gravitationally dominant, that was pulling on these distant worlds. A hidden world, perhaps, orbiting far beyond Neptune. For decades, astronomers had speculated about an undiscovered planet in the outer solar system. The idea of a Planet X had haunted the imagination of scientists and dreamers alike since the 19th century. But with the discovery of Neptune in 1846 and later Pluto in 1930, those hopes seemed fulfilled. Pluto was initially thought to be that missing planet, the one that balanced the gravitational pull of Uranus and Neptune. Yet, as measurements improved, Pluto's small mass shattered that illusion. It was far too tiny to have any significant effect on its neighboring worlds. And so the dream of a ninth planet faded, dismissed as a relic of a less precise age of astronomy, but the universe, as it often does, had another story to tell. In 2016, two astronomers at Caltech, Konstantin Batygin and Mike Brown, revisited the mystery with new eyes and new data. Brown, famous for discovering several dwarf planets and for demoting Pluto from planethood, had spent years exploring the Kuiper Belt. Yet what he and Batygin found next was beyond anything they expected. When they plotted the orbits of 6 distant objects, all with elongated paths far from the sun, they noticed something astonishing. Each orbit was tilted in a similar direction, and their closest approach points to the sun. What astronomers call perihelia were grouped together like compass needles, all pointing the same way. This was no coincidence. In physics, when patterns like this appear, they demand explanation. Batygin and Brown ran countless simulations, testing every known factor, the gravitational effects of the known planets, random scattering from passing stars, and the galactic tide, the subtle pull of our Milky Way's mass. Yet none of these could reproduce the observed clustering. Only one explanation fit. There had to be a massive, unseen planet shepherding these distant objects into place. This revelation reignited a fire in the astronomical community. If such a planet existed, it would be the true ninth planet, a world 5 to 10 times more massive than Earth, orbiting the Sun on a long, elongated path. It would be so far away that sunlight takes hours to reach it. It would take thousands, perhaps tens of thousands of years to complete a single orbit. And yet, despite its distance, its gravity would be powerful enough to shape the very structure of the outer solar system. The realization that our solar system might still be incomplete was both thrilling and humbling. For centuries, humanity believed we had mapped our cosmic home in full. From Mercury's scorched surface to Neptune's frozen winds, every world seemed accounted for. But now a shadow had appeared beyond the known frontier, suggesting that we still had much to learn, that the map of our solar system was not yet finished. The evidence for Planet 9, as Batygin and Brown named it, was not seen through a telescope, but felt through its effects. Like a ghost planet, its presence was inferred from the way it tugged on smaller objects, and that's what makes the mystery so powerful. It's not about what we can see, but what we can deduce. It's about reading the gravitational fingerprints left behind by an unseen architect. The Kuiper Belt, once considered a quiet backwater of our solar system, suddenly became a stage for one of the greatest astronomical detective stories of the century. Each newly discovered object was like a clue, a piece of a puzzle that, when assembled, revealed the faint outline of something massive lurking in the cold dark. Astronomers began to scan the sky with renewed purpose, searching for that elusive glimmer of reflected sunlight that might betray Planet 9's position. But even with our most powerful telescopes, the search has proven daunting. The distances involved are staggering. If Planet 9 truly exists, it could be hundreds of times farther from the Sun than Earth, buried in a region where sunlight is a faint whisper. Its faint glow would be lost among countless background stars, barely distinguishable from cosmic noise. To find it requires patience, precision, and a little bit of faith, the kind of faith that drives humanity to keep looking even when the odds seem impossible. Still, the evidence continues to grow. The orbits of more and more Trans-Neptunian objects show the same clustering, as if something massive is herding them together. Their paths twist and bend in a way that perfectly fits the gravitational influence of a distant giant. Even the tilt of the solar system itself, a slight 6-degree lean relative to the Sun's equator, could be explained by the presence of Planet 9. It's as though this hidden world has been quietly shaping our solar system for billions of years, unseen but always present, like the foundation of a building buried beneath the ground. The idea that something so vast could remain undiscovered in our own celestial neighborhood is both haunting and awe-inspiring. It reminds us that space, even close to home, remains a frontier of mystery. We often think of exploration as something that belongs to the past, the age of Galileo, of Voyager, of the first steps on the moon. But Planet 9 reminds us that there are still frontiers to cross, still discoveries waiting in the dark. It is a reminder that the universe is not a completed story but an unfolding one, and we are still turning the pages. What makes this mystery even more fascinating is how it challenges our assumptions about order and chaos. We imagine the solar system as a clockwork of predictable orbits, each planet following its own precise path. Yet beyond Neptune, that order begins to fray. The Kuiper Belt is wild, full of eccentric orbits and tilted planes. But what if that chaos isn't random? What if there's a hidden symmetry behind it, a gravitational composer arranging the music of the cosmos from afar? Planet 9 could be that composer, the unseen architect creating harmony in what we once thought was disorder. And yet, despite the growing evidence, some scientists remain skeptical. They remind us that extraordinary claims require extraordinary proof. Maybe the clustering of orbits is just a coincidence. Maybe our telescopes have only observed a biased sample. Or maybe there are other, subtler forces at play, the collective gravity of thousands of smaller objects, for example. But even the skeptics admit that the mystery demands investigation. Whether Planet 9 exists or not, something is happening in the outer solar system that we do not yet understand. And perhaps that is what makes this story so profoundly human. Throughout history, every time we thought we had reached the limits of knowledge, we found another horizon waiting. Every time we thought we understood the sky, a new mystery emerged, from the moons of Jupiter to the rings of Saturn, from Pluto's icy plains to the dark energy that drives the expansion of universe. Planet 9 is the next step in that endless journey, a reminder that curiosity is the most powerful force we possess. In the vast silence beyond Neptune, something is whispering to us, not in light, but in gravity. It's a whisper that says there is more, more to discover, more to understand, more to see. And so, the search continues, not just through telescopes and equations, but through the human spirit itself, which refuses to stop asking questions. Because the mystery beyond Neptune is more than a scientific puzzle. It's a mirror reflecting our own desire to know the unknown, to reach into the darkness and pull out meaning. It's proof that the cosmos still holds secrets, that wonder is not something we've outgrown. And as astronomers track the faint motions of distant icy worlds, they are not just studying gravity, they are chasing a dream, the dream of finding something that was always there but never seen. Perhaps one day, the faint glimmer of a distant world will appear in our telescopes, a slow-moving point of light against the endless black. And when that happens, humanity will once again expand its boundaries, realizing that even after all these centuries, the map of our solar system was incomplete. Until then, Planet 9 remains an unseen presence, a ghostly architect in the farthest darkness, shaping our world from the shadows. And that, in itself, is a beautiful reminder that even in silence, even in the void, the universe is alive with design, waiting for us to listen closely enough to hear it. The theory of Planet 9 was not born from imagination alone. It was born from the stubborn precision of mathematics and the quiet conviction of two astronomers who refused to look away from patterns written in the darkness. In 2016, Konstantin Batygin and Mike Brown at Caltech announced something that reignited humanity's fascination with the edge of our solar system. They didn't claim to have seen a new world. Instead, they had felt it, not with their eyes, but through its invisible pull on everything around it. They noticed that the distant icy bodies beyond Neptune were behaving strangely, as if caught in the gravitational embrace of an unseen giant. It was a whisper in the data, but one so compelling it demanded attention. Brown, known famously as the man who killed Pluto, was not a man easily seduced by speculation. Years earlier, his discovery of several Pluto-sized objects forced astronomers to redefine what it means to be a planet. He was a realist, perhaps even a skeptic about adding another world to our planetary family. And yet, together with Batygin, he found something that no skeptic could easily dismiss. The orbits of 6 remote Kuiper Belt objects were not random. They were eerily similar, aligned in space, as though something massive was herding them into formation. The duo calculated that these small bodies, often no larger than a few hundred kilometers across, could not possibly influence each other. Their only logical master was gravity, but whose? Not Neptune, not the collective mass of the Kuiper Belt. No known object could exert such distant, coherent control. The simplest and most powerful explanation was that another planet existed, one several times more massive than Earth, orbiting far beyond Pluto's frozen realm. This planet, if real, would not be a twin of the worlds we know. It would not glow with reflected sunlight or shine with rings. It would be an exile, an ancient survivor from the solar system's chaotic youth, perhaps flung outward by Jupiter's gravitational violence billions of years ago. Some simulations even suggested that Planet 9 could be a captured wanderer, a rogue planet once drifting between the stars before being ensnared by our sun's gravity. If so, it would be a cosmic orphan, adopted into our family, but forever kept at arm's length. The numbers told a story of scale and solitude. Planet 9 was estimated to be 5 to 10 times the mass of Earth, large enough to be a Neptune, a world of dense atmosphere and icy layers, perhaps cloaked in methane or ammonia frost. It would orbit the Sun at an average distance of 400 to 800 astronomical units. That's 400 to 800 times the distance between Earth and the Sun. To put that in perspective, Neptune's orbit lies at only about 30 astronomical units. Planet 9, if it exists, is not merely beyond Neptune, it is far beyond imagination. At such a distance, the Sun would appear as nothing more than a bright star in the sky, its warmth almost meaningless. The planet's surface temperature would hover near absolute zero, a place where air freezes and light takes hours to travel across the vastness of its orbit. And yet, this frozen world's gravity could stretch across trillions of kilometers, subtly tugging on the orbits of smaller objects, sculpting the solar system's outer structure like an invisible hand. Battigan and Brown's hypothesis wasn't just a wild idea, it was built on cold, precise evidence. Using simulations, they modeled what would happen if a large, distant planet orbited the Sun at a steep inclination, tilted compared to the known planets. The results matched reality. The mysterious clustering of trans-Neptunian objects, their odd orbital tilts, and even their shared direction of motion all emerged naturally when Planet 9's influence was added to the model. When it was removed, the patterns vanished. What made the theory so beautiful was its simplicity. In physics, beauty often lies in the ability to explain many mysteries with a single elegant idea. Planet 9 did exactly that. It unified the chaos of the outer solar system into a story of harmony and design. The distant objects previously thought to be scattered by random chance suddenly made sense. Their paths were not arbitrary, they were following an invisible conductor. But this wasn't the first time astronomers had used unseen gravity to predict a hidden world. In the 19th century, the orbit of Uranus didn't quite fit Newton's equations. Two mathematicians, Urbain Le Verrier in France and John Couch Adams in England, independently calculated that another planet must be tugging on Uranus, a planet that had yet to be discovered. Their calculations led to the discovery of Neptune in 1846, almost exactly where mathematics predicted it would be. Planet 9, many realized, could be the modern equivalent of that moment, a discovery made not by sight, but by reasoning, by faith in the laws of nature. Still, Planet 9's orbit, so vast and stretched, was unlike anything in our known solar system. It challenged the way we thought planets formed. Traditionally, planets coalesce from a disk of dust and gas around a young star, orbiting roughly in the same plane. But Planet 9, if it exists, seems to move at a steep angle, perhaps 15 to 25 degrees off that plane. It's as if it's been knocked askew by some ancient cosmic event, perhaps a close encounter with another passing star billions of years ago, or a violent gravitational dance with Jupiter and Saturn. That sent it hurtling outward. This raised deeper questions. How many such exiles could there be? Could Planet 9 be just one of several hidden worlds roaming the dark periphery of our solar system? Some astronomers began to speculate that the Sun might have a dark retinue, a small population of massive, icy planets that drift beyond detection, leftovers from the solar system's chaotic youth. If so, our solar system would be far more complex and majestic than we ever imagined. Yet, for all its scientific grounding, Planet 9 remained stubbornly elusive. Telescopes scanned the regions of sky where simulations suggested it might be hiding, but found nothing. Part of the difficulty lies in its distance and faintness. Even a planet several times the size of Earth would be almost invisible at that range, reflecting only a tiny fraction of sunlight. Its motion across the sky would be so slow that it could take months of careful observation to confirm. Caltech team estimated that Planet 9's brightness might be about 1,000 times fainter than Pluto's. Searching for it would be like looking for a single moving grain of sand in a desert of stars. Every night, astronomers photograph the same section of sky, hoping that one faint dot will shift ever so slightly against the background. It's an act of patience and persistence, a cosmic treasure hunt that could take years, perhaps decades. Despite the difficulty, the theory has continued to evolve. More objects have been discovered whose orbits fit the same strange alignment pattern, strengthening the case. The orbital clustering is not random, it's statistically significant, and the more we find, the more persuasive the evidence becomes. Even skeptics admit that something unusual is happening in the outer solar system. Whether it's one large planet or a distributed mass of smaller bodies remains uncertain, but the gravitational imbalance is undeniable. What makes Planet 9's story even more fascinating is that it bridges the gap between the known and the unknown, between human intuition and cosmic truth. It shows how science often begins with mystery, not with certainty. Astronomers didn't start by seeing the planet, they started by seeing what didn't make sense. They followed the evidence through the darkness, guided only by the belief that nature leaves clues, even when it hides its secrets. There's something profoundly human about that pursuit. We've always searched for the unseen, from ancient explorers who sailed into unknown oceans to modern scientists peering into the void. Planet 9 represents that same impulse, the refusal to accept that the map is complete. It's an act of rebellion against the idea that we already know everything. For Batygin and Brown, the search has become both scientific and philosophical. Each new discovery of a distant icy object adds weight to their model, refining the predicted orbit of Planet 9. They've narrowed down the regions of sky where it might be found, a vast arc, stretching across constellations like Taurus and Eridanus. Somewhere in that patch of darkness, a silent world may be waiting, unseen yet constantly influencing the dance of smaller worlds around it. And as we await confirmation, the imagination fills in the blanks. What would such a planet look like? Would it be a deep blue sphere like Neptune, swirling with frozen winds? Would it have moons, perhaps even a thin ring system glimmering faintly in the distant sunlight? Could it be a world of ancient storms and buried oceans, where heat from its core keeps a secret sea alive beneath an icy shell? Or would it be nothing more than a cold, airless rock, locked in eternal night? The truth could be stranger still. Some models suggest that Planet 9's composition could make it more similar to Uranus and Neptune, a mini gas giant with a thick atmosphere of hydrogen and helium wrapped around a rocky core. Others propose that it might even have faint internal heat, slowly radiating the energy it was born with billions of years ago. That heat, faint but real, could make it slightly brighter in the infrared spectrum, offering another path for detection through specialized telescopes like the Subaru Observatory in Hawaii. The mystery of Planet 9 has also captured the imagination of storytellers, dreamers, and philosophers. It reminds us that not everything that shapes our world is visible. Gravity itself is an invisible force, silent, constant, unrelenting, and yet it defines the structure of everything from galaxies to atoms. Planet 9 is the embodiment of that truth, a world that cannot be seen, yet whose existence can be felt. In many ways, Planet 9 is a metaphor for the hidden influences that shape reality, just as unseen gravity guides the paths of distant worlds, unseen truths guide human life. We are all pulled by forces we cannot see: hope, curiosity, love, ambition. They are our internal gravities drawing us toward discovery, shaping the orbits of our decisions. The search for Planet 9, then, is not just a quest for another planet. It is a mirror held up to humanity's endless need to seek what lies beyond the known. As the years pass, new telescopes rise to meet the challenge: the Vera C. Rubin Observatory, with its sweeping view of the sky, will soon begin its decade-long survey, scanning the heavens in exquisite detail. If Planet 9 exists, it may finally reveal itself there, not as a bright discovery headline, but as a quiet point of light moving slowly through the dark, confirming what our equations had already whispered. Until that day, the hypothesis stands as a testament to the power of deduction and imagination. It reminds us that the universe is never finished revealing its secrets. Even now, at the edge of knowledge, a planet may be waiting, ancient, cold, unseen, guiding the distant reaches of our solar system with silent authority. And perhaps that is the most poetic truth of all, that the unseen can still shape the scene, that even in darkness there is order, and that the story of our solar system is far from over. Planet 9 may be out there, the hidden giant, the unseen architect, the quiet ruler of the farthest frontier, waiting for the day when human eyes, guided by human wonder, finally find it. The most compelling evidence for Planet 9 does not come from what we can see, but from what we can measure, from the quiet, mathematical fingerprints left behind by its gravity. In a universe ruled by invisible forces, gravity is the great sculptor, shaping the structure of galaxies, the paths of comets, and the very dance of planets around stars. Even when the sculptor itself cannot be seen, its work is unmistakable. The strange behavior of distant icy worlds in our solar system, known as Trans-Neptunian objects, tells us that something massive is lurking beyond Neptune's frontier. The orbits of these tiny, frozen relics are like whispers from the dark, revealing the presence of a giant we cannot yet behold. When astronomers plotted the paths of these Trans-Neptunian objects, small, icy worlds scattered across the Kuiper Belt, they expected randomness. After all, beyond Neptune, the sun's influence weakens, and countless small bodies should be freely wandering through space, unaffected by any single dominant force. But when data began to accumulate, a pattern emerged that defied that expectation. Many of these objects shared an eerie symmetry. Their elongated orbits all pointed in roughly the same direction. Their perihelia, the closest points of their orbits to the Sun, were clustered together like compass needles drawn to an invisible north. This pattern was not a coincidence. Statistically, it was so improbable that random chance could not explain it. The probability that these objects just happened to align this way was less than 1 in 1,000. Something unseen, something gravitationally powerful, was orchestrating their motion. Astronomers began to realize they were seeing the gravitational shadow of a massive planet far beyond what any telescope had yet captured. To understand this influence, imagine throwing a handful of pebbles into a still pond. Each pebble creates ripples that spread outward, colliding and overlapping. Normally, those ripples would cancel each other out, creating chaos on the water's surface. But if one large stone were thrown into the pond first, heavy and dominant, its waves would define the pattern, forcing the smaller ripples to align around it. That is what Planet 9 seems to be doing, shaping the structure of the outer solar system, not through visibility, but through presence. Mathematical models show that if a planet 5 to 10 times the mass of Earth exists far beyond Neptune, its gravitational reach would be immense. Even though it would be hundreds of astronomical units away, its steady pull could influence the orbits of smaller icy bodies spread across vast distances. Like a slow tide, its gravity would sweep through the Kuiper Belt, pulling certain objects into synchronized orbits while scattering others into the darkness. The result would be exactly what we observe today, a family of distant objects all aligned in a single, ghostly formation. Astronomers Konstantin Batygin and Mike Brown, the Caltech scientists who first proposed Planet 9, ran thousands of computer simulations to test this idea. They adjusted the mass, distance, and orbital tilt of the hypothetical planet to see which combination could reproduce the strange clustering of real trans-Neptunian objects. Time after time, the same conclusion appeared. A planet roughly 10 times the mass of Earth, orbiting the Sun every 10 to 20,000 years, could naturally generate the observed orbital alignments. Remove that planet from the simulation, and the pattern fell apart into chaos. Add it back, and the order returned. The invisible architect had been mathematically revealed, but the story doesn't end with alignment. The orbits of these distant objects don't just point in the same direction, many of them are also tilted at similar angles. This means that Planet 9 isn't merely pulling them along the same line, it's twisting their paths in three-dimensional space. The tilt of these orbits can only be explained by the gravitational torque of a massive body moving on an inclined orbit itself. In other words, Planet 9's orbit is not perfectly flat relative to the plane of the known planets. It's tilted, a celestial giant moving on a slanted path, bending the fabric of the solar system around its hidden axis. This realization opened a deeper understanding of how interconnected our solar system truly is. Even from its remote position, Planet 9's gravity could subtly influence the orientation of everything beyond Neptune. It might even explain why the entire solar system's orbital plane is tilted by about 6 degrees relative to the Sun's equator. For centuries, that small tilt had been a quiet puzzle. Now it seemed the answer might lie with a planet we've never seen. A single distant world could be holding the solar system at a slant, exerting its will from the cold outer dark. There are other hints, too. Some objects in the outer solar system have orbits that are mysteriously perpendicular to the rest, almost 90 degrees off the plane. Their existence had baffled astronomers for years, but in simulations that include Planet 9, these high-inclination objects appear naturally. They are the cosmic debris of gravitational interactions, bodies that were once ordinary Kuiper Belt objects, thrown into wild orbits after close encounters with the hidden planet. Planet 9's presence turns chaos into predictability. Its gravity sculpts the bizarre into the inevitable. Even more intriguing are the so-called detached objects and bodies whose orbits are too distant to be explained by Neptune's influence. Take Sedna, for instance, one of the most mysterious worlds in the solar system. Sedna follows an elongated orbit that takes it from 76 astronomical units at its closest to the Sun to nearly 1,000 astronomical units at its farthest. Neptune's gravity cannot reach that far, and no known mechanism can account for Sedna's path, unless, of course, there's another planet lurking in the darkness, guiding Sedna's motion from afar. Planet 9 in this context becomes not a speculative idea, but the simplest explanation for the existence of Sedna and other similar worlds. Every piece of evidence, every orbit, every tilt, every alignment adds another brushstroke to the invisible portrait of Planet 9. The patterns are too deliberate, too structured, to be the result of chance. The solar system, it seems, bears the fingerprints of an unseen designer, its influence etched into the icy debris at the edge of the Sun's reach. But this is not the first time humanity has uncovered a hidden planet through its gravitational clues. The discovery of Neptune in the 19th century followed a similar path. Astronomers noticed that Uranus was not moving exactly as predicted. Its orbit showed subtle deviations, as though another unseen body was tugging on it. By applying Newton's laws of gravity, scientists predicted where that missing planet should be, and when they looked, there it was, almost exactly where the mathematics had said. Planet 9 could be history repeating itself, another triumph of reason over darkness, another moment when invisible forces revealed a new world. Yet, despite the compelling evidence, Planet 9 remains elusive. No telescope has yet captured its faint reflection. Its gravity is felt, but its light is unseen, like a ghost planet haunting the edges of our understanding. The problem is partly one of scale. If Planet 9 exists, it could be so far away that sunlight barely touches it, and the light it reflects would be fainter than the dimmest star our eyes could ever perceive. Even the most advanced telescopes would struggle to distinguish it from the background noise of distant galaxies. Still, astronomers persist. The search continues with powerful instruments like the Subaru telescope in Hawaii and the upcoming Vera-C. Rubin Observatory in Chile. These observatories are capable of scanning vast areas of the sky, taking deep exposures night after night, looking for the slowest, moving objects among billions of stars. Planet 9, if it's out there, will move only a fraction of an inch across the sky over the course of an entire year. Detecting it requires not just technology, but patience, the kind of patience that only comes from faith in evidence. Meanwhile, the gravitational fingerprints grow clearer. Astronomers continue to discover more distant icy objects whose orbits conform to the same peculiar alignment. Each new discovery strengthens the case, like a new clue in a cosmic investigation. The number of objects following this strange pattern has increased steadily since 2016, and their orbits all point toward the same invisible source. It's as if the universe is leaving breadcrumbs for us to follow, each one drawing us closer to the truth. Even skeptics, who once dismissed the theory as coincidence, now admit that the evidence cannot be ignored. The challenge is not in proving that something is influencing these orbits, that much is clear, but in proving exactly what it is. Some propose that the combined gravitational pull of countless smaller icy bodies could mimic the effects of a single planet. Others suggest that an ancient passing star might have tilted the orbits long ago, but none of these explanations fully match the precision of Planet 9's gravitational model. The simplest, most elegant solution remains. There is a massive planet out there, and we just haven't seen it yet. The beauty of this theory lies not only in its science, but in its symbolism. It reminds us that the universe is shaped by what we cannot see. The same way gravity shapes orbits, invisible forces shape our lives, forces like love, ambition, fear, and hope. We don't see them, but we feel their effects. They pull us toward one another, push us toward our goals, and shape the paths we take. Planet 9, in this sense, is a cosmic metaphor, a reminder that unseen does not mean unreal, and that the most powerful forces often operate in silence. Think about the elegance of it. Billions of miles from the sun, beyond the reach of light, an unseen world silently choreographs the motion of frozen relics left over from the birth of our solar system. It has no need to announce itself, no need to shine. Its gravity alone is enough to leave its mark on the universe. In that way, it mirrors the quiet power of truth itself, invisible yet undeniable, and so we stand in an age much like those who first predicted Neptune centuries ago. We are again at the edge of knowledge, guided by faith in the laws of nature and the precision of mathematics. We have seen the ripples, now we must find the stone. The gravitational fingerprints are there, written across the heavens, pointing towards something vast, cold, and magnificent. Perhaps one day soon, our telescopes will finally capture it, a faint point of light, moving slowly against the black. When that day comes, it will not just be a discovery of a planet, it will be the confirmation of an idea, the triumph of deduction over darkness. But even if it remains hidden, the search itself is proof of something greater, that humanity's curiosity knows no bounds, and that we will always follow the evidence, no matter how faint, into the unknown, because gravity doesn't lie. It speaks through the stars, through the motion of worlds, through the quiet precision of the universe itself. And somewhere beyond the edge of sunlight, Planet 9 is speaking, not in words, but in the language of alignment and pull, shaping the distant heavens in ways we are only beginning to understand. The search for Planet 9 has become one of the greatest scientific pursuits of our time, a modern-day treasure hunt that blends mathematics, physics, and raw curiosity. But unlike any ordinary treasure, the prize here is not gold or jewels, it's understanding. What drives this quest is the same force that has always pushed humanity forward, the hunger to know what lies beyond. Yet finding something so distant, so faint, and so elusive is not easy. Planet 9, if it exists, is likely one of the most challenging objects ever sought in the night sky. The difficulty of its detection has made it a ghostly enigma, a whisper in the dark, always just beyond the edge of our instruments. To grasp how hard it is to find this unseen world, imagine standing in a vast moonless desert at night, holding a tiny flashlight and trying to find a single grain of sand among billions, except that the grain is moving slowly, silently, across a field of glowing stars. That is the scale of the challenge astronomers face. Planet 9 could be between 400 and 800 astronomical units from the Sun. That's 400 to 800 times farther than Earth. At such a distance, sunlight becomes almost meaningless. The faint illumination that reaches it is dimmer than the glow of a candle seen from 1,000 miles away. Even if Planet 9 reflects sunlight like a mirror, it would still appear unimaginably faint to our telescopes. To detect it, astronomers must scan enormous regions of the sky, sometimes over hundreds of nights, comparing images taken months apart to spot any object that moves against the fixed backdrop of stars. Most stars remain perfectly still in such photos, but a planet, even one so distant, will shift slightly, just a few pixels across. That minute motion, that barely perceptible drift, could be the clue that unveils the greatest planetary discovery of the century. The search began in earnest around 2016, when astronomers Konstantin Batygin and Mike Brown at Caltech published their groundbreaking paper suggesting Planet 9's existence. Using data from dozens of Trans-Neptunian objects, they showed that the peculiar alignment of their orbits could not be explained by chance. Since then, the race to find Planet 9 has become a global effort, involving teams of astronomers across continents and observatories spread across both hemispheres. The Subaru telescope, perched atop Mauna Kea in Hawaii, has played a leading role in this hunt. Its wide, field hyper-subprime cam allows astronomers to image large swaths of the sky in great detail. But even with such advanced technology, the search is painstakingly slow. The region where Planet 9 might reside covers thousands of square degrees, an area so vast that scanning it entirely could take years. And the planet's apparent brightness is expected to be at the very edge of what Subaru can detect. Every night of observation is a test of patience, skill, and persistence. Astronomers use a technique called sky differencing. They take multiple images of the same region at different times, sometimes weeks or months apart. Then they subtract one image from another. Stars and galaxies, being distant and stationary, cancel out, leaving only moving objects behind. These moving dots could be asteroids, comets, or, if the universe blesses us, the faint signal of Planet 9 itself. But each frame may contain thousands of false positives, noise, cosmic rays, or image artifacts that mimic motion. Sorting through these is an enormous computational task, often requiring advanced algorithms and artificial intelligence to identify genuine candidates. But the challenge is not only technological, it's also astronomical. The sky is vast, and Planet 9 could be hiding anywhere along its immense orbital path. We don't yet know where it is in its orbit, whether it's near its closest approach to the Sun, perihelion, where it would be relatively brighter, or near its farthest point, aphelion, where it would be almost invisible. If it's at aphelion, Planet 9 could be over 1,0 astronomical units away, a distance so great that even our best telescopes might struggle to detect it. Yet, despite these obstacles, the clues keep accumulating. Astronomers have identified more distant icy bodies whose orbits follow the same strange pattern predicted by the Planet 9 hypothesis. Each new discovery refines our estimate of where the planet might be. With every calculation, the map of possibility narrows. We are closing in, inch by inch, pixel by pixel, on the hidden architect of our solar system. Technology has been both our greatest ally and our greatest limitation. While telescopes like Subaru and Pan-STARRS can scan wide areas, they are still limited by the Earth's atmosphere, which distorts faint light from distant objects. That's why the upcoming Vera C. Rubin Observatory in Chile is so eagerly anticipated. Equipped with a massive 3.2 gigapixel camera, the largest ever built for astronomy, it will survey the entire visible southern sky every few nights. When it begins full operation, it will create a time-lapse movie of the universe, allowing astronomers to track even the faintest moving dots over time. If Planet 9 exists and lies within reach, the Rubin Observatory is expected to find it. But until that moment comes, astronomers must contend with uncertainty, and that uncertainty is a heavy companion. Every search night is filled with both hope and frustration. Hours of data analysis might yield nothing but noise. Nights of clear skies might end in silence, and yet the pursuit continues because the potential reward is too profound to abandon. Finding Planet 9 would not just add a new world to our solar system, it would redefine our understanding of how the solar system formed, evolved, and continues to be shaped by unseen forces. The emotional side of this search is something often overlooked. Science is not just logic and numbers. It's a deeply human endeavor driven by passion. Astronomers spend their lives staring into the void, looking for something that may not even exist, because the idea of not knowing is unbearable. There's a quiet poetry in that, in humanity's refusal to accept ignorance, in our willingness to chase faint whispers across the cosmos. Planet 9, in that sense, has already changed us. Even if we never find it, the search itself has pushed our instruments, our imagination, and our endurance to new limits. Mike Brown, who helped kill Pluto's planetary status in 2006, now finds himself searching for the very planet that could restore our count back to 9. There's irony and redemption in that. For him and others, this pursuit is personal. It's not just about proving a theory right. It's about uncovering truth in the most remote corners of the universe. Every night under the stars, every faint glimmer analyzed through screens, carries the weight of that purpose. Yet, skepticism remains an essential part of science. Some astronomers argue that the evidence for Planet 9 could be an illusion, the result of observational bias. Perhaps we've only discovered those Trans-Neptunian objects that happen to be in certain regions of the sky, creating the appearance of clustering where none truly exists. Others suggest that instead of one massive planet, the combined gravity of countless small icy bodies could produce the same orbital effects. These alternatives are not without merit, and they remind us that science thrives on doubt. Certainty is the end of discovery, but doubt keeps the search alive. That tension between belief and skepticism, between hope and restraint, is the heartbeat of the Planet 9 search. Every new observation has the potential to shift the balance. One clear detection of a faint, slow, moving dot could change everything. One verifiable image could silence doubt and rewrite textbooks. Until then, astronomers live in a state of suspended wonder, not yet knowing, but never giving up. Beyond the technical challenge lies a deeper philosophical one. If Planet 9 exists, it means our solar system is not a simple, orderly place. It's a dynamic, evolving environment full of surprises. It means that our models of planetary formation, built on centuries of observation, still have blind spots. It suggests that massive planets can form or be captured far from their stars, perhaps remnants of cosmic encounters billions of years ago. It could even mean that our sun once brushed past another star, exchanging material like two ships passing in the night, and that Planet 9 is a relic of that ancient meeting. Such possibilities remind us that the solar system is not an isolated system, but part of a grand cosmic network. Stars are born together in clusters, drift apart, and sometimes interact. The story of Planet 9 could be the story of such an interaction, a reminder that even in the vastness of space, nothing exists in complete isolation. For those searching for it, Planet 9 has become almost mythical, a symbol of persistence, mystery, and the unknown. Every generation of astronomers has had its great challenge: the discovery of Uranus, the detection of Neptune, the identification of Pluto. Each one pushed the boundaries of what was thought possible. Now, in the 21st century, Planet 9 is that frontier, the next great mystery calling to us from the dark. And what happens if we never find it? What if, after all the years of searching, all the data and calculations, the universe remains silent? Then even that silence will teach us something. It will tell us that the strange orbits of distant worlds arise from other causes, from subtle interactions, from the combined gravity of countless small bodies, or from events long forgotten. In that case, Planet 9 will not vanish in disappointment, but live on as an idea that guided us toward greater clarity. Because in science, even being wrong leads us forward. But if we do find it, if that faint light finally appears, it will be one of the greatest discoveries of our time. Imagine it, a planet 10 times the mass of Earth, orbiting in eternal twilight, its surface frozen and silent, bathed in the faint glow of a distant sun. It will redefine the boundaries of our solar system and expand the map of our cosmic neighborhood. The textbooks will change, the diagrams will shift, and the story of our solar system will gain a new, unexpected chapter. And humanity, for all our fragility, will have once again reached farther into the unknown, because that's what defines us, this relentless need to explore, to seek, to uncover the hidden. Planet 9 may be invisible to our eyes for now, but its influence has already reached into our imagination. It has reminded us that even in an age of satellites and supercomputers, the universe still holds secrets. And those secrets call to us, as they always have, across the cold expanse of space. We are, after all, the species that looked up at the stars and decided to understand them. The search for Planet 9 is simply the latest expression of that ancient impulse, the refusal to accept mystery as permanent. Somewhere in the distant dark, a faint world may be waiting, orbiting in silence, carrying within it the story of our solar system's past. And whether we find it tomorrow or a century from now, the pursuit itself will remain one of the most beautiful acts of faith our species has ever performed. faith not in myth or magic, but in quiet power of evidence, persistence, and wonder. If Planet 9 exists, its story is not merely one of mystery and distance. It's a story of power, of influence, and of deep cosmic architecture. To understand it is to see our solar system not as a collection of isolated planets, but as a living, breathing organism shaped by forces we still barely comprehend. The very structure of the outer solar system, the strange orbits, the tilted planes, the icy debris fields stretching into darkness, may all be the signature of this unseen world. Planet 9 could be the architect that sculpted the outer edges of our celestial home, ensuring its harmony and balance across billions of years. When we look at the solar system today, we see order. The planets move in predictable paths around the Sun, following the laws Newton and Einstein taught us. But the deeper we peer into the distant reaches beyond Neptune, the more that order begins to fray. There the Kuiper Belt, the great icy ring of leftover planetary material, grows erratic. Small bodies move in elongated, tilted, and sometimes perpendicular orbits. Some of them, like Sedna and 2012 VP 113, travel so far from the Sun that they seem disconnected from the rest of the solar family. Their paths do not obey the gravitational rules we would expect if the 8 known planets were all that existed. Something else, something massive, is shaping them. Planet 9, if real, provides an elegant explanation. Its gravitational influence could act like a cosmic shepherd, guiding and restraining these faraway objects, preventing chaos and maintaining a kind of hidden order at the edge of the Sun's domain. Imagine a maestro conducting a symphony, but doing so from behind a curtain. The music continues, every note falling into place, even though we cannot see the hand that commands it. That is what Planet 9 may be, the invisible conductor of the solar system's outermost music. Simulations of the solar system that include Planet 9 reveal an astonishing truth. Over millions of years, this distant planet could stabilize the orbits of countless Trans-Neptunian objects, keeping them from scattering into interstellar space. Without its influence, the outer solar system might have long ago descended into disarray, a chaotic cloud of drifting ice and rock. Instead, the presence of this massive world imposes structure. It corrals these distant objects into families of aligned orbits, giving shape to a realm that would otherwise be formless. In this sense, Planet 9 doesn't just exist at the edge, it defines the edge. It sets the boundaries of the Sun's gravitational kingdom, marking the point where order fades into interstellar wilderness. It might even explain why our solar system is so unusually neat compared to others. In many exoplanetary systems, giant planets wander close to their stars, causing instability and disruption. But in our system, the giants Jupiter, Saturn, Uranus, Neptune occupy harmonious orbits, while the unseen Planet 9 quietly shapes the outer rim. Its gravitational hand may be subtle, but it could be the very reason the solar system has remained so balanced for billions of years. There is another fascinating possibility. Planet 9 might be a captured planet, not one born of our Sun. During the early days of the solar system, when the Sun was still forming within a dense cluster of newborn stars, close encounters between stars were far more common. In that chaotic environment, our Sun could have stolen a rogue planet from a passing star's system, pulling it into its gravitational grasp. Over time, this foreign world would have settled into a vast, distant orbit, too far to be illuminated, yet close enough to exert influence. If that's true, then Planet 9 is not just a missing member of our solar family, it's an adopted one, a cosmic orphan taken in by our Sun billions of years ago. If Planet 9 were captured, it could help explain several lingering mysteries about our solar system's structure. For one, it might account for the 6-degree tilt of the entire planetary system relative to the Sun's equator. For centuries, this small but persistent misalignment puzzled scientists. The Sun spins one way, but the planets orbit in a plane slightly askew. Where did that tilt come from? One possible answer is Planet 9. Its inclined orbit, stretching deep into space, could be tugging on the rest of the solar system like a counterweight, slowly shifting the orbital plane of all the other planets over billions of years. Its influence might also explain the orbits of certain high inclination and retrograde objects, small icy bodies that move in ways that seem to defy logic. Some of these orbits are tilted nearly 90 degrees, and a few even travel backward relative to the planets. Without an external force, such orbits should not exist, but when Planet 9 is added into the equations, the chaos suddenly makes sense. The plan, its immense gravity can nudge smaller objects into extreme tilts, and reverse their directions through long-term interactions. Over time, its invisible influence sculpts the outer solar system into the intricate, multi-layered structure we see today. This gravitational sculpting extends even to the comets that occasionally visit the inner solar system. The long-period comets, whose orbits span tens of thousands of years, originate from the distant Oort cloud, a vast spherical shell of icy debris far beyond Pluto. Planet 9 could play a crucial role in perturbing some of these comets, sending them inward toward the Sun. Each time we see a glowing comet streak across the night sky, it might be carrying a silent message from Planet 9, a fragment of ice flung inward by its distant gravitational command. Even more compelling is the way Planet 9's existence might unify our understanding of the solar system's evolution. For decades, scientists have puzzled over the distribution of material in the outer regions. Why does the Kuiper Belt end so abruptly around 50 astronomical units? Why do certain objects have orbits that seem disconnected from Neptune's influence? The presence of a massive planet beyond Neptune could neatly explain all these anomalies. Its gravity could have cleared and reshaped the outer belt, sweeping away debris and carving the sharp boundary we observe today. There's something profoundly poetic about this possibility. For billions of years, while life was forming on Earth, while humans were still only a dream of evolution, this hidden planet may have been guiding the solar system's architecture from the shadows. Every snowball of ice, every small world at the edge of the Sun's reach, has moved in silent obedience to its pull. Planet 9 may not be visible to our eyes, but its mark is written in the stars, encoded in the orbits of worlds that still whisper its presence. If we could somehow stand on Planet 9, if we could set foot on its frozen surface and gaze upon the Sun, it would appear as nothing more than a bright star in the black sky. The warmth we know on Earth would be absent, the light would be dim and cold, casting long shadows over an endless plain of ice and rock. The air, if any existed, would be razor, thin and silent. Yet from that lonely vantage point, we would look back at the inner solar system and see it as a distant cluster of faint lights, all of human history, all of life, compressed into a single shining point. From there, we would realize how immense and interconnected everything truly is, how a single distant world can shape the destiny of all the others. It is humbling to think that a planet so remote could have such a profound influence, but that's the nature of gravity. It does not need proximity to exert power. It reaches across emptiness, binding everything together. The Sun's gravity keeps the planets in orbit. Jupiter's gravity protects Earth by catching stray comets, and perhaps Planet 9's gravity holds the outer solar system in harmony. The universe is a web of invisible connections, and Planet 9 might be one of its most important threads. If confirmed, this discovery would force us to rethink what we know about planet formation. It would show that large planets can exist at enormous distances, surviving the chaotic birth of solar systems. It would suggest that the early sun was surrounded by a far more complex structure than we once imagined, perhaps a disk of material stretching thousands of astronomical units, rich enough to form not 8 but 9 worlds. It would also tell us that our solar system is not unique. In fact, astronomers have already detected exoplanets orbiting their stars at similar distances. Planet 9, then, would be the bridge between our system and the broader galactic pattern. Its confirmation would ripple across disciplines: planetary science, astrophysics, cosmology, because it would show that even after centuries of exploration, our solar system still holds secrets. It would reignite the spirit of discovery that defined earlier eras, when each new planet found expanded humanity's sense of wonder. When Uranus was discovered in 1781, it doubled the known size of the solar system. When Neptune followed in 1846, the map grew again. Planet 9 would extend that map to unimaginable distances, redefining the frontier once more, and yet, beyond the science, there is a deeper meaning. Planet 9 represents the unseen structure that gives order to apparent chaos, a metaphor that resonates far beyond astronomy. In life, too, there are invisible forces that shape our paths: love, fear, belief, destiny. We may not see them, but their influence is undeniable. The orbits of our choices, the patterns of our lives, are pulled by gravity we cannot measure but can always feel. Planet 9 reminds us that the unseen can be just as real, just as powerful as what we can observe. Perhaps that is why the idea of Planet 9 captures the imagination so deeply. It's not just about adding another name to the list of planets, it's about confronting the limits of our knowledge and daring to look beyond them. It's about believing that the universe still holds mysteries worthy of pursuit. Somewhere out there, in the frozen dark, an invisible architect continues to guide the rhythm of our solar system. Whether it is a captured rogue, a leftover from creation, or something entirely unexpected, its story is entwined with ours. Someday, when the faint glimmer of Planet 9 is finally captured by our telescopes, it will not be just another scientific discovery, it will be a revelation. We will see, for the first time, the hidden world that has silently shaped our cosmic home. And in that moment, we will be reminded once again of the most enduring truth of all, that the universe is vast, mysterious, and full of wonders waiting for those brave enough to search. Until that day, its presence lives in equations and in faith, in the subtle alignments of ice worlds billions of miles away, in the way gravity bends time and space, in the quiet conviction that cosmos still has more to tell us. Planet 9 may dwell in the shadows, but its influence is everywhere, written into the very architecture of our solar system. It is the unseen sculptor, the silent guardian of order beyond chaos, and perhaps the final piece of our celestial puzzle. The search for Planet 9 is not just a scientific pursuit, it is a reflection of the timeless human spirit. Discovery of another so make dist, ain't sure the word. It is a symbol of our innate hunger to explore, our refusal to accept the boundaries of the known, and our deep, almost spiritual connection to the cosmos. For thousands of years, humanity has gazed upward at the night sky, tracing patterns in the stars, seeking meaning in the infinite. Every age has had its mysteries, and every mystery has driven us forward. In this modern age, Planet 9 is one of those mysteries, a silent reminder that the universe still keeps secrets from us, that wonder still exists beyond the glow of our cities and the reach of our machines. There is something profoundly poetic about the idea that even now, after centuries of exploration and the launch of countless probes, our solar system still hides a massive world. We have mapped Mars in exquisite detail, flown past Pluto, sent spacecraft beyond the edge of the sun's influence, and yet, just beyond our reach, there could be an entire planet waiting to be found. It humbles us, reminding us that no matter how far we advance, the universe remains infinitely larger, older, and more mysterious than our imagination. Planet 9 stands as proof that the cosmos is not finished revealing itself to us. Throughout history, the discovery of new planets has always expanded not just our scientific knowledge, but our philosophical horizons. When Uranus was discovered in 1781, it shattered the ancient conception of a finite solar system, showing that the heavens were not a closed system, but an ever-expanding realm. The discovery of Neptune, predicted by mathematics before it was ever seen, proved that human reason could reach into the dark and pull truth from the void. Planet 9, if found, would continue that legacy. It would be the next great triumph of intellect, patience, and imagination. But even more than that, it would reaffirm something essential about who we are. Humanity has always been defined by curiosity, the restless urge to seek what lies beyond. From the first sailors who ventured past the horizon to the scientists who sent probes to the edge of the solar system, we have never stopped asking questions. The hunt for Planet 9 is an extension of that same instinct. We are explorers not just of space, but of truth itself. And every time we find something new, we redefine what it means to be human. There's also a quiet emotional dimension to this quest, one that transcends science. When astronomers point their telescopes toward the deep sky, they are not just gathering data, they are expressing faith. Faith in order, faith in the idea that the universe makes sense, even when it seems chaotic. Faith that behind the random motions of icy worlds, there is a hidden logic waiting to be uncovered. To search for Planet 9 is, in a way, to participate in a conversation with the universe, to ask a question with mathematics and wait for the cosmos to answer. And what an answer it would be! If Planet 9 is found, it will not only rewrite our textbooks, it will rewrite our sense of scale. Imagine standing outside on a cold night, looking up at the stars, knowing that beyond Neptune, beyond Pluto, beyond even the farthest reaches of the Kuiper Belt, there exists another world, a frozen giant orbiting in eternal twilight, untouched for billions of years. To comprehend that is to feel the weight of eternity pressing gently against the mind. It would be a reminder that our solar system is not a closed chapter, but a living story still being written. Yet the beauty of this pursuit is not just in the possibility of discovery, but in the act of seeking itself. The search for Planet 9 embodies the essence of science as a human endeavor. It is a pursuit born from observation, sustained by persistence, and driven by the conviction that truth, no matter how deeply buried, can be found. It unites people across nations, cultures, and generations. Astronomers in Japan, Chile, the United States, and Europe all contribute their data, all share the same goal: to find that faint, moving point of light that will prove what the equations already whisper. And while the telescopes scan the heavens, the idea of Planet 9 continues to ripple through human thought. It challenges our sense of finality. It reminds us that knowing is never complete, that every discovery opens new questions. What if there are more? What if Planet 9 is not alone? Could there be even more distant worlds, Planet 10, Planet 11, or entire systems of objects orbiting in the unseen depths? These questions ignite imagination as much as intellect. They remind us that exploration is endless. In the silence of space, Planet 9 becomes a mirror for our own existence. It reminds us of our smallness, yes, but also of our potential. The same species that once feared the stars now reaches for them. We have learned to turn curiosity into technology, wonder into understanding. From a fragile planet orbiting a modest star, we have built instruments capable of detecting the faintest traces of light billions of miles away. That transformation of awe into knowledge is the story of humanity itself. There's also something deeply spiritual about the search. Not in the sense of religion, but in the sense of connection. Every discovery, every new world, deepens our relationship with the universe. It reminds us that we are not separate from it, we are part of it. The atoms in our bodies were forged in stars that lived and died long before the sun was born. The same gravity that guides Planet 9 also binds us to the Earth. The universe is not out there, it is within us, around us, and through us. Planet 9 is just another thread in that vast cosmic tapestry, a hidden one, perhaps, but no less beautiful for being unseen. And yet, for all its mystery, Planet 9 also teaches us patience. We live in an age of instant information, where answers are always at our fingertips. But the universe does not move at our pace. It reveals itself slowly in whispers and patterns, across decades and centuries. The search for Planet 9 reminds us that truth takes time. It asks for humility, the willingness to work, to wait, and to believe without immediate proof. It teaches us that discovery is not a moment, but a process, a long dialogue between observation and understanding. It also challenges our perception of what it means to be seen. Planet 9, if it exists, has always been there. Its gravity has shaped the orbits of distant objects for billions of years, influencing the structure of our solar system long before humanity evolved. It didn't suddenly appear when we began to look for it. It was simply unseen. In a way, this mirrors so much of human experience. Often, the most important things in life, love, faith, meaning, are not visible, yet they shape us profoundly. The invisible does not mean the unreal. Sometimes the unseen is what holds everything together. Perhaps that is why the idea of Planet 9 resonates so deeply, even beyond the realm of science. It touches something primal within us, the desire to find order in mystery, to understand the hidden architecture behind the visible world. In our personal lives, as in the cosmos, we are often guided by forces we can't see. The search for Planet 9 becomes a metaphor for that journey, the quest to uncover what's hidden, to bring light to the dark corners of our understanding. And what a revelation it will be if we finally find it. When the faint light of Planet 9 appears on a telescope's image, a tiny, slow, moving dot amid billions of stars, it will be more than a scientific victory. It will be a triumph of human spirit, a proof that patience, logic, and imagination can pierce even the deepest darkness. That the universe, vast as it is, still yields to the curiosity of the small creatures who dwell within it. But even if we never find it, even if Planet 9 remains forever unseen, its search will not have been in vain, because every observation made, every calculation run, every icy object discovered along the way brings us closer to understanding the structure of our solar system. Each failure refines our knowledge, each night of scanning the stars deepens our connection to them. The journey itself becomes the reward. The process of searching sharpens not just our science, but our sense of wonder. In the end, Planet 9 represents the best of humanity, the courage to question, the persistence to seek, and the humility to accept that we do not yet know everything. It tells us that our story is far from over. Even now, in the 21st century, when we've sent machines to other planets and peered into galaxies billions of light years away, there are still discoveries waiting just beyond our doorstep. The cosmos is reminding us that there is always more to learn, more to see, more to understand. Perhaps that is Planet 9's greatest gift, not its gravity, but its meaning. It reminds us that the universe is alive with mystery, that discovery is infinite, and that wonder is eternal. It calls to us from the cold edge of the solar system, whispering the same message the stars have always whispered: keep looking, and so we will. We will continue to build better telescopes, refine our models, and push deeper into the unknown. We will trace every clue, follow every orbit, and listen to every gravitational whisper until the truth reveals itself. Because that is who we are. We are seekers of knowledge, dreamers of the cosmos, children of the stars. Planet 9 may still be hidden, its light too faint for us to see, but its influence is everywhere in the tilt of worlds, in the pull of comets, in the quiet alignment of icy bodies drifting through the dark. And in that way, it already exists not only as a physical world, but as an idea, a symbol of the unseen forces that shape both the cosmos and the human heart. One day, perhaps soon, a telescope will find it, a faint point of light moving slowly against the black. Astronomers will confirm it, and humanity will once again stand on the threshold of discovery, but even before that moment, Planet 9 has already done its work. It has reminded us to wonder, to question, to look beyond what we know. It has reminded us that the universe, vast and ancient, still holds surprises for those who are willing to look up and believe that there is more. It has reminded us that exploration is not an act of distance, but of vision. And most of all, it has reminded us that even in the silence of the cosmos, there is always something waiting to be found, something that connects us to the infinite and to each other. Planet 9 may be unseen, but its greatest discovery is already here, in us, in our unending desire to understand the universe we call home.